Alright, what a great way to solve the daily Leetcode problem in Swift, because we have a WWDC 2026 coming in next 3 or 4 hours. Alright, so today's Leetcode problem is partition array according to the given pivot. So we are given a zero-index integer array nums and integer pivots, and we have to rearrange the nums such that the following conditions are satisfied. So every element which less than the pivot that is given in the function have to be left on the before the pivot, but every element is equal to the pivots appear in between these two elements and are less than or greater than to the pivot. So I think that is pretty simple. Okay, maybe we go with the example given in here. So we are given like the numbers in here, and maybe I have a simple idea. How about we use a 3 array? Let's go like left, which is the middle will be pivot, and right will be everything greater than here. So we can simply do the dry run from each index, start from here. So if it is less than the pivot, we put the 9 in left. So 9's come here, and then we're gonna move our index to next 12, which is greater than our 1. So we put the 12 in here, and then 5, which is less than 10. So we put the 5 in here. And next is 10, that is a pivot we put in the middle. And 14, which is greater than the pivot, and we put in here. And 3, we put in here. And 10, we put in here. So we are pretty much done. And at the end, we combine all these 3 arrays into one, and we just return as a result. So that is one idea. I think the same in here. So 2 is in the middle, and then put the -3, 4, and 3 on the right. So I think that's pretty straightforward. How about if we want to save instead of using the 3 array, we can do like 2-point approach, like left and right directly, and then we can check like if it is left, we'll do the like one dry run. So instead of like going through like all the way around, so we will do the dry run, and then we will move all the number across. Okay, how about we start our solution with using the 3 array? Let's go left, which is going to be the integer. I'm gonna copy that, middle, and right. Cool. And let's call this as a count. No, we don't need a count. We can directly go through it. For none in nuns, what I'm going to do is num is greater than less than the pivot. We will put that middle value, the value in the left num. And else if num is equal to pivot, we will put in the middle. Num also okay, pivot also okay, because the value are the same. And last but not least will be the right. And at the end, we can just return like left, middle, and right. Let's do the run locally. I think the time and space complexity of this approach is O of n, because we are not using any extra data structure aside from array. What if we want to use only one array? So maybe just use one array as a reset, and then let's do an array of repeating of 0, and then count will be the count. We have a count in here, and we will have two pointer, which is left and right. That will be count minus 1. Cool. And for that, I'm gonna do the index in 0 through count if our nums of index is less than the pivot. What I want to do is I will shift the value on the left. So let's say we are in here. We will check the left index. So is pivot is greater than our current left index. What I want to do is I want to put that on the left. So left will be nums of index. And next is I'm gonna move the index into the +1 so that we are heading to here. The same approach for the next is the right index, which is going to be the count minus 1 minus index. Technically we can use a count because count is probably like 1, 2, 3, 4, 5, 6, 7. It will show the 7 that will be index out of bounds, so do the -1. And then we still remove the index, which is currently valued as 0. And then we will check is greater than pivot. So if the value is greater than, technically we want to do is reset of right, which is the last index of the reset, will be put in the nums of count minus 1 minus index, and we will increment the right index by 1. So if everything went well, what we only need to do is we have to keep updating of the pivot. So we will check if because we have assigned the value like left and right here. Let's show through like we have an answer array. These are like 0 at the moment, 0 at the moment, 0, 0, and 0. So next is here. Oh, I just saw that one mistake. We should not be increment, we should be decrement the value. So next, we will also check if 12 is greater than or less than. We will check. So if index is greater than our pivot, I'm gonna put in the 12 in here, which is in here. 3 will be in here, and I will move. There we go. There we go. And 5 is less than, put here. And 3, yeah, 3 is already put, and 14 is supposed to be in here. Yep, we are both in here. And then which is also already done that time. After that, what we need to do is we're going to check the left and right index. We want to make sure that right is still greater than or equal to the left. If yes, what we can do is we can update the result of left index by putting the pivot, and I will increment the left until it's break our while loop, and then just return the result. I think this approach is a little bit more practical than the previous approach. So if everything went well, we can check the big O notation together. I think it's probably O of n for both time and space complexity, because we don't use any spare data structure outside of the given array. Alright, as we expected, the time complexity of O n and the space complexity also O of n. Hope you guys enjoyed my video, and please go and watch the WWDC if you enjoyed the Swift. Thanks, and I'll see you in the next one. Bye!